I personally don't. My wife made them all up, so I just borrow her. She also teaches this class.
Like every class, we do like 3 sheets, and I'm like, okay, I'm tired.
Yeah, she. The way she does it, she actually prints them all out for the entire chapter, so she can just pick hand out and stuff. Yeah, I just do it individually. Yeah, she teaches down the hall at 327. Yeah, we'll actually have 2 reviews. We'll have one that we'll have in class on Monday, because your test is next Wednesday. We'll have a worksheet for in class, and then there'll also be an out of class review. So you'll actually have 2 of them. Yeah. Other questions at all? Yeah, so today we're going to start our last new section that we're going to cover before the exam. So we'll spend today and Friday on this section. On Friday we'll do another quiz over just factoring techniques. So remember last time we talked about the review of factoring techniques. So we'll have a 4-question quiz on Friday, just to make sure that you can pick out which factoring techniques you're supposed to use when. Okay, so that'll be on Friday. Monday will be devoted to review for the exam. Okay, so we'll talk more about what the exam is going to look like. I'll have an in-class review sheet that you can work on, and I'll come around and help on that on Monday. There will also be an additional review sheet posted on Moodle for an out-of-class review to get extra problems, and there will be answers posted on those as well. Say again? The Hawks, there's a review on there too. Yep. Yeah, and that should be open. You can do that now if you want to. It's due on Tuesday. Oh, that's just all your hand. By the way, you had a question. Other questions at all? All right, so like I said, today we're going to talk about the last new section before the exam, and that is the section on polynomial equations. So talking about doing some equation solving ideas. So everything we've done up until this point is just factoring. And we're going to, like I said before, pretty much any other math class that you take past this one, you're going to do factoring in it, one way or another. So all the way up until you do even 400 level classes in math, so senior level math classes, you do factoring. Okay? So it's an important skill to have, so we're going to be coming back to it. So this is kind of our first application into factoring. The types of polynomials we've been factoring, especially when we started using the AC method, are called quadratic equations. That just means that the highest power of x that you see is a 2. So you have an x squared term in there, you have an x term in there, and you have a constant term in there. So that's what we mean by quadratic equations, or quadratic polynomials are just quadratics. When we talk about a quadratic equation, then, we're talking about there's a polynomial, a second-degree polynomial on the left-hand side, and 0 on the right-hand side. That's our standard form for a quadratic equation. And our big technique for solving these types of equations will be put everything on one side and have 0 on the other and factor. That's going to be our big technique for doing it. The reason why, when you think about multiplying 2 numbers together, if I multiply 2 numbers together and I get 0, what has to be true about at least one of the 2 numbers? One of them has to be 0, right? If I multiply 2 things together and get 0, one of them has to be 0. And that's what we refer to as the 0 factor property. That's what's listed here in your notes there. The 0 factor property says that if I have a product, I have a multiplication that gives me 0, then at least one of them had to be 0. So let's see how this applies to this particular quadratic equation here that we have. We have x squared plus 3x minus 10 is equal to 0. Notice this is already in what we refer to as standard form because we've got that equals 0 on the right-hand side. Let's factor the left-hand side. How does that factor, that x squared plus 3x minus 10? How can we factor that? Okay, so we had an x plus and an x minus for certain, right? Why do I know it's a plus and a minus? What tells me that? Yeah, that sign in the middle is negative. The sign on the constant is negative here, right? So I need to multiply to negative 10 and add to positive 3. What do we need to use? Yeah, a plus 5 and a minus 2. Again, if you want or need to use AC method on that, you can. Because again, I would use plus 5 and minus 2 as my factors of 10 to give me plus 3. And you can do your factor by grouping bit that we do with the AC method. So now again, we have a product that equals 0. So by the zero factor property, that tells us that, don't need that parenthesis, that either the x plus 5 is equal to 0 or the x minus 2 is equal to 0. One or the other had to happen. So if I solve the x plus 5 equals 0, what would I do? Yeah, subtract the 5 over to the other side, right? Subtract 5, we would get x equals negative 5. Over here, what will we do? Add the 2 to both sides, and we get x is equal to 2. Say it again. Okay, go ahead and sit here. Wait, I didn't sit here. Good question. We want to go all the way to the end here. What the x value is. So the x equals negative 5 and the x equal to 2. So the x plus 5 and the x minus 2 give us the equations that we need to solve to get to the final answer. Okay. This okay? So far, so good? So let's see if we can do these first couple of practice problems. Notice right away, this first practice problem here isn't a quadratic to start with because we've got an x cubed, right? An x to the third power here. So this is actually would be a cubic polynomial since the highest degree power is 3 or cubed. But we want to still attack this like we've done every other factoring problem. Okay. The only thing that you have to make sure that you do first in these problems is make sure that you have 0 on one side. If you've got x's on both sides, the first thing you need to do is move everything to one side. Okay? Because we want to factor it. Having a product of things equal to 3 doesn't tell you anything. Or having a product of things equal to negative 7 doesn't tell you anything. You need a product equaling 0 to tell you something. Okay? So the first step will always be move everything to one side. So now let's go through and factor. What's our first thing we look for factoring? GCF. What is the GCF here? 2x. Yep, I got a 2 in all my constant, all my coefficients, and everything has an x in it, right? So let's factor out that 2x first. What are you left with when you factor out the 2x? So we pulled that 2x out in front, factored out that 2x, leaves us with 3x squared plus x minus 4. So far, so good? Okay. Got a GCF out. Let's factor this. What should we use to factor that? AC, right? What do we do first for AC? Yeah, the 3 times the negative 4, right, gives us negative 12. So let's list out our factors. And again, if you can do this without listing out your factors of 12, that's fine. I just like to do it so we can see what the factors are. What things multiply together to give us 12? 1 and 12, 2 and 6, 3 and 4, and that's all the pairs we have, right? Since we had minus 12, what does that tell us? Yeah, one has to be positive and one has to be negative, right? So what are we going to use so that we get a plus x in the middle? 3 and 4? Which one's going to be positive? 4, right? You need a a plus 4 and a minus 3. Okay. So we'll put that in the middle. Do you factor by grouping now? What can you factor out of the first two terms? X leaves you with the 3x plus 4. So then what do we need to factor out of the second two terms then? -1, good. And that leaves you with 3x plus 4, which is better, right? If it's going to factor, I need to see the same group in the first set and the second set. That's a 1. It's just sideways a little bit. It was like a backslash. You don't have to put the 1 there if you don't want to, but it kind of helps when you factor it out, right? Because how does that factor now? Be 3x plus 4 times x minus 1. Good. Have we done anything different so far than what we've done in this entire chapter? No. Literally what we've been practicing, right? This is literally what we've been doing the entire chapter. The only thing new now is that we've got a product of things equaling 0, right? If a product is equal to 0, then what does that tell us? One of them has to be 0, right? In this case, I've got 3 factors, so we'll have 3 equations to solve. So the first part would be 2x has to be 0, or 3x plus 4 has to be 0, or x minus 1 has to equal 0. This is today's lecture, right? Set each factor equals 0. It's literally that's today's new stuff, right? Okay. What do we do to both sides to get this one? Divide by 2. It gives us 0, right? So we'll do divide both sides by 2. We'll get x equals 0. This one's going to require us to do a couple of steps, right? We've got to subtract the 4. And then divide by the 3. And so we'll get -4 over 3. And in the last one, we need to plus 1. Good. I didn't leave myself a lot of room on that one, did I? So that middle one required 2 steps, right? We needed to subtract the 4 to the other side and then divide both sides by 3. Get -4/3. Okay. One thing I like to notice, in that first example we did, we had an x squared term. That was the highest power we had. How many answers did we get? Well, the first example. 2. This one, the highest power was 3. We got 3. That's not an accident. Okay. All right. So let's do the next one here together, and then we'll talk about that last one, and then I'll set you loose on the practice problems and come around and answer questions. First thing we look for, well, first thing, make sure you've got equal to 0 on one side, right? That's step 1, okay? Which we do. What's the first thing we look for? GCF, in this case, is 5. When we factor out a 5, what are we left with? Good. Are we okay with getting the GCF out of there? Okay. This has 2 terms, right? If it's going to factor, when we have a 2-term polynomial, it's going to have to fit one of those special forms, right? Which one does this fit? Difference of squares, right? Okay. So, again, if you don't need to do this next step, you don't have to. but I like to write it out just so that we can see what's going on. What do we, didn't mean to move that. What do we square to get 9x squared? 3x, good. What do we square to get 16? 4. So how does that factor now? 3x plus 4 and 3x minus 4, right? You do need to know those special forms for the exam, right? I'm not going to give those to you. You need to know how those factor, those 3 special ones. Okay. Now what do we do? Yeah, set each one equal to 0, right? Now technically I've got 3 factors again, right? Okay. You're exactly right. There's not an x. I'm still going to write it down, but you're exactly right. So this would say that 5 would have to equal 0, right? Or 3x plus 4 is equal to 0, or 3x minus 4 is equal to 0. All right. Now, does that first equation that I wrote down make any sense? Is 5 equal to 0? No. So this one doesn't give you anything. Notice that it's different, right, than the previous one. What's different about this one with the 5 versus the one we did before? The one we did before has an x, right? This one does not. So you're exactly right. That one doesn't have an x, so it didn't have any answer at all. The next one, we would subtract 4 again from both sides and then divide by 3. Okay. The only thing different with the other one, we would, instead of subtracting 4, we would add it. Good. And then divide. And so this would be our answer then here. What was the highest degree of x we started with? 2. How many answers did we get? 2. It's okay? What questions do you have on that one? So far, so good? All right. Now notice that this one is, the second part here, or this third part, I guess I should say, is basically asking the problem in reverse. This says, I want my answers. So, by the way, when we say the word root, that means solution. Okay? It means it gets 0 when you plug it in. That's what we mean by the word root. The word comes from the fact that if you think about graphing, the x-axis is kind of ground level. So that would be where it crosses the x-axis with rooted there. That's where the word root comes from. Okay. Anyway, that's why we call them roots. We just mean solutions. So we want the answers to be 3 and 6. Let's go back to the original problem we solved. Where did this -5 answer come from? Where did it come from? The x plus 5, right? Where did the x equal 2 answer come from? X minus 2, right? So going back down here, if I want 3 as an answer, where do you think it's going to come from? X minus 3. If we want 6 as an answer, x minus 6. So this is the equation that we created, right? We know the answers were 3 and 6. To get an answer of 3, I would need x minus 3. To get an answer of 6, I would need x minus 6. The last part asks us to multiply out the factors, so it wants you to multiply out the left-hand side. This is just practice for doing multiplication. What do we get when we multiply out the left-hand side? That's probably good. We're reviewing that then. What do we get when we multiply out the left-hand side? How do we multiply out the left-hand side? Let's start there. Yeah. Say again. Take a 1. What do you mean take a 1? Oh, take the multiply the x through. Is that what you're telling me to do? Yeah, because I want to work it backwards, right? I want to take the factors and multiply them out. So what do I need to do with this x here? Times the x and times the 6, right? So we get x squared minus 6x, and what do we get? Negative 3x and plus an 18, right? That, remember, those multiplying out polynomials is going to be on your exam too, right? Just want to make sure we went through this. Okay. Remember, everything in your first factor has to get to multiply by everything in your second factor, right? I have to do my x times my x and my x times my minus 6, my minus 3 times my x and my minus 3 times my minus 6. And so then we combine our negative 6 and negative 3x to get negative 9x. That okay? What I want you to do is practice on that those problems that I gave you. There's a front and a back there. Work on those. I will put up solutions as we go to these. Yeah. Okay. I would use the AC method. You used to actually use it as well. Use the AC method when you have a coefficient under x squared and under that. Yeah. I mean, you could do it a different way if you want to, but I would use the AC method on those. Nope, that's it.